Oi.
Silent tu tak terbuka.
Tiga grup ni kan kak?
Good afternoon. Due to some technical errors, we need an extra 10 minutes. Please do wait. Thank you. Sorry for the inconvenience caused. We would like to start now. Good afternoon, ladies and gentlemen. Selma Sejatra, Vanakkam, and a very warm welcome to each and every one of you. I'm Miss Divashni, and I'm truly delighted to be your host and MC for this special occasion. It is my absolute pleasure and honor to welcome you to the closing ceremony of the Engineering, Science, and Technology Exhibition ST 2026 with a theme of Shaping the Future with Innovation Solutions. It is truly inspiring to reflect on the incredible ideas, creativity, passions showcased throughout today's event. Ladies and gentlemen, before we officially begin this event, it is my honor to acknowledge the distinguished guests and esteemed leaders who are with us today. We are deeply privileged to acknowledge our sponsor, the finest Touch Empire and Strata Bina Sindrian Berhad, for generous contribution for our SD 2026 Series 1. Thank you, the finest Touch Empire and Strata Bina Sindrian Berhad. We are deeply privileged to welcome our Deputy Dean of School Information Technology, Ms. Hawaii, and our Head of Research Engineering Built Environment and Information Technology, Brigadier General Retired Prof. IR, Dr. Noor Azman bin Muhammad Noor. Our esteemed speakers, Captain Retired Dr. IR Technologies Azrul, Afandi Mustafa Al Bakri, and Architect Hussam Abdul Fattah Harun. We are honored to welcome our participants from Masa University, University Technology Malaysia, Institut Kemahiran Tinggi Belia Negara Sepang, Sunway College, Kuala Lumpur, Dr. MGR Educational and Research Institute, Chennai, India, Segi University, Mentari International School, Jakarta. We are also honored to have with us the judges and our panels from Masa University, Absolute Mark PLT, Advanced Geomechanics Sidran Berhad, Dyson Ltd Senai Johor, University of Cyberjaya, University Tun Hussein on Malaysia, Sunway University, Alpha Infotech, Dr. MGR Educational and Research Institute, Chennai, India, Agency Nuclear Malaysia, and Kumpulan Teknologi Penilaian Logi PA team, as well as esteemed members of the management team, distinguished lecturers, and the dear students. Thank you all for your gracing this event with your presence. Now, ladies and gentlemen, before we proceed further, let's take a moment to honor our nation and our institution. May I kindly invite everyone to rise to sing our national anthem Negaraku, followed by our Masa University song. Please let us all stand together in unity and pride.
Di sini kita warnai kehidupan, menggapai cita, mengotakkan impian. Kita sang juara, meneraju cemerlang, selaluan gemilang, aspirasi negara dijulang. Semakin keyakinan seluruh warga, kita mantapkan jaringan antara bangsa. Disinilah profesional berjaya, kitalah dia di pentas dunia. University masa lambang kejayaan, University masa satu kemuliaan, University masa menuju kemasyhuran, University masa pasti pilihan. Berdaya saing, berinovatif, berdedikasi, berintegriti, melahirkan Islam berkualiti, bangsa jadikan satu realiti.
Thank you, ladies and gentlemen. You may now please be seated. Now, ladies and gentlemen, it is my great honor to introduce Captain Retired Dr. IR Technologist Azul Afandi Mustafa Al Bakri. He is highly respected professional with extensive experience in military engineering, infrastructure development, and strategy operations. He is currently the managing director of STARE Resources, Sindhuram Berhad, where he continues to lead innovation engineering solutions that support both national and humanitarian needs. With professional titles such as Doctor, IR Technologist, he represents excellence in academic achievement, engineering expertise, technological competency. Throughout his career, he has been actively involved in critical areas such as bridge deployment, structural engineering, and rapid response infrastructure, which is particularly in challenging and high risk environments. He is especially well known for his work in modular bridge systems, which are essential for rapid deployment during the disaster relief operations, supporting military logistics, and improving connectivity in remote or affected areas. Today, he will be sharing his insight through his keynote titled Bridging the Gap Role of Modular Bridges in National Security and Humanitarian Missions. Ladies and gentlemen, please join me in giving a big warm welcome to Dr. Captain Retired Dr. IR Technologist Azrul Afandi Mustafa Al Bakri. Please put your hands together.
Hello and good afternoon, everyone. Thank you very much, Miss Chairperson, uh, for the introduction for myself. Uh, Ladies and gentlemen, guest lecturer, student from Massa University and others invited institution. Hopefully, everybody in a good condition and good health today. First of all, I would like to thank you to Massa University, especially to Faculty of Engineering, Built Environment, and IT for inviting me as keynote speaker in conjunction of Engineering, Science, Technology Exhibition, or ESTE 26. I'm pleased to attend this session and deliver a talk and sharing as an industry practitioner. My full name, as mentioned or introduced by the Ms. Chairperson, and also can open my slide. Okay, let me add on beyond the introduction of me. Previously, I'm served in Malaysian Armed Forces or Malaysian Army since 2002 and retired. I choose early retirement in 2017. So I have experience about 15 years, and my department or my core is a engineering core. So I handle, I manage, and my operation most on the structure, building, water, roads, and other infrastructure. Especially for military, secondary tasks to support national development or humanitarian mission. I just complete my PhD in civil engineering from National Defence University of Malaysia or UPNM, and just graduated last year. And for your information, my main supervisor is Brigadier General Professor Dr. Nozman in front of me. Thank you, sir. Okay, today I would like to talking about modular bridges, especially how they play a critical role in both national security and humanitarian missions. Okay, now when we talk about bridges, most people think about permanent infrastructure like in highways or in city bridges. But today I want to introduce or give an introduction, a different perspective. Bridges that are mobile, fast to deploy, and can operate in extreme condition and also can relocate to other location. These are modular bridges And in many real world situations, especially during emergency, these bridges are not just useful, but they are essential. Let me start with a simple, powerful idea about bridges. Bridges are lifeline. It's not only infrastructure. Imagine a situation where a flood destroys a bridge. Suddenly, an entire community becomes isolated. This can be happen in villages or also can be happen in cities. Rescue teams cannot enter, medical aid cannot reach victims, food and water supplies are delayed. In a military context, it even more critical. If a unit cannot cross a river, all the military assets cannot move forward. So what happened? Operation are delayed and logistic breakdown. That's why in military we often say no bridge, so no movement and also no mission. So that is the criticality of the bridge in army and so military. So this is the problem that modular bridges are designed to solve. The previous photo is a belly bridge deployed in one of state in north of Malaysia, in Baling, Kedah. So this is after the flood. During the flood, the water washed away the bridges, and we need army and also public works department to construct a temporary bridge using belly bridge. So what is exactly a modular bridge? A modular bridge is a bridge made up of prefabricated components. These components are manufactured in a controlled environment, especially in factory. Then they are transported to the site and assembled on location. Think of it like Lego blocks, but engineered for real loads. Each part has a specific function. It's panel, decking, screws, and other components. The key advantage here is a speed and flexibility during the construction at the site. Unlike conventional bridges, you don't need long construction time. Normal construction time for conventional bridge is 1 to 2 years, and if a big bridge is maybe can go up to 3 years. But with modular bridge, you can construct the bridge in 1 day, and sometimes with modern or new modular bridge, you can construct in just an hour. You can deploy it quickly, use it, dismantle it, and use again somewhere else. Okay, so you can see the component. Okay, at the right or at your left side, you can see the component of the modular bridge. This one is a belly bridge. I think this is extensive use during World War II and still evergreen and used until today. This is an evergreen technology. So you can see how the installation or the launching of the bridge. Okay, I think okay. So this is an example of one type of the modular bridge. We call it belly bridge. I think all around the world call it belly bridge. Belly is the name of the inventor, Sir Donald Bailey, who invented this bridge during World War II for the Allied forces, and now being used all around the world. Okay, so the component is fabricated in the factory, then stockpile at a nearest camp or nearest store. Then if we need it, we transport it to site, to the remote area or village or disaster stricken area, and then maybe 1 to 2 days we can have a complete bridge that we can restore the access. I think I want to share the one video to give you a view of the how the belly bridge is construct. This is just an animation video. So you just imagine when the bridge destroy or wash away, you cannot go to the far bank. All works or installation or construction need to do in one site only. So this bridge uses concept of cantilever launching. All component is assembled and installed at the one side, and after that we uh, push to the far bank. So if you can see, all component is similar for one module, and repetition. The installation or the construction is a repetition process, and all component is interchangeable. There is no front side or right side or back side. You can take any component and start construct. That's the key of the modular bridge. The flexibility and the easy for the operator. Okay, during the cantilever launching, the operator or the army will push the bridge, and this is the critical point that they have to aware that the center of gravity of the bridge. The rule of thumb, the weight of the back side must be heavier than front side. So okay, then they dismantle the launching nose, the front side, and after that they start to install the decking of the bridges. Okay, now the bridge is ready for crossing. Okay, I continue with next slide. So, basic engineering concept for the modular bridge. Most modular bridges use a truss system. Why truss? Because triangular structure are inherently strong. When a load is applied like a vehicle crossing, the forces are distributed across multiple members in the truss. This reduces stress, concentration, and increase overall stability. So even though the bridge is made of relatively lightweight component, it still can carry heavy loads. This is a great example of how smart engineering design can achieve both strength and efficiency. Next. Okay, for design consideration for any modular bridge, first is the span length and how long is the bridge we want to construct, or how wide is the gap. Second is load capacity, what type of vehicle need to cross. Are we talking about car, truck, or heavy military vehicle? Third is ground condition, whether the soil is stable enough to support the structure. Fourth is deployment time, how urgent is situation. Okay, in Army we have several type or category of modular bridge. We have assault bridge that can be constructed within minutes. Then we have a tactical bridge, we can construct in hours. Then we have a logistic bridge. Logistic bridge we construct in days, 2 to 3 days. And finally, the logistic, how easy is the transport of the bridge component to the site. All these factors influence the final design and selection of the bridge system. Okay. How modular bridge play role in national security? Mobility is one of the most important factors. Military forces need to move quickly, whether for defense, support, response of operation, or humanitarian mission. Modular bridges allow troops and equipment to cross obstacles like river or destroy bridges. For example, tank can cross river, supply vehicle can reach frontline unit, engineering teams can restore road quickly. Without this capability, operation can be delayed or even fail. Behind every military or emergency operation, logistic plays a critical role. You need to move fuel, ammunition, food supply, medical team. So modular bridge ensure that this supply chain remain uninterrupted. Now let's move to humanitarian mission. In disaster like floods or landslide, infrastructure is often damaged or destroyed. Entire communities can become isolated within hours. Modular bridges can be deployed rapidly to restore access. This allows rescue team to enter affected areas, aid to be delivered quickly, evacuation of victims. This is especially important in the first 72 hours, which the most critical period in disaster response. Next. Okay, let we go through a typical scenario case study. A flood destroyed a bridge in a rural area. So bridge villages are cut off. Within a short time, engineering team deploy a modular bridge. So bridge collapse, access cut off. Modular bridge deploy, access restore. Okay. Then let me share some real world example. During World War II. During World War II, belly bridge were used extensively in Allied forces. Major bridges were built across the Rhine River in Germany. Okay. The left photo, you can see the belly bridge is constructed on the river, and because the span is too long, then they make it like a floating bridge. So they need a pontoon at the middle of the river to support the bridge. Then they continue construct the following span. Any global conflict zone, these bridges support both military operation and humanitarian aid delivery. This example clearly show that modular bridges are not just engineering solution, but they are strategic assets. This one case study in Malaysia. So the situation is a seasonal monsoon flood damaged the bridge. Then the rural communities isolated for several days. The solution as government sent belly bridge by army and also public works department and deploy the bridge rapidly. So during this period, they managed to construct the bridge and restore the access within 3 days. Next. Okay, future trends in modular bridge. Looking ahead, the future of modular bridge is very promising. We are seeing new materials like fiber reinforced polymer, composite material, which is lighter but still strong. We are also seeing faster deployment system and even automation system. Some concepts involve robotic or semi-autonomous deployment. This innovation will make modular bridges even more efficient and versatile. Next. Okay, these are just highlight for students. To all students here, engineering is not just about theory or exam. It is about solving real world problems. You can see the codes the common course. Engineer is one who solve problems that you did not know existed in ways you do not understand. So you is actually know nothing, but you have to solve that problem. What we learn in university or our in a higher institution or in college cannot solve the real problem outside there. So engineer must be always innovative and hardworking to find a way or solution. Okay, to conclude, bridges are more than structures. They connect people, communities, and missions. Modular bridges represent speed, adaptability, and impact. They show how engineering can respond to real challenges when times is matter most. Okay, thank you very much. I hope this session is has useful for all audience, especially the student. I'm happy to take any question if you have.
Is there any questions?
If no, I am okay.
Okay.
Okay, thank you, ladies and gentlemen.
Thank you, Captain, for insightful and inspiring sharing. May I kindly request Captain to be present on the stage to receive tokens of appreciation. May I kindly invite Head of Research Engineering Built Environment and Information Technology, Brigitan General Retired Professor IR Dr. Rorazman bin Muhammad Noor to the stage to present the token of appreciation. We would like to present tokens of appreciation to our distinguished speaker as a gesture of our gratitude to Captain Retired Dr. IRTS Azrul Afendi Mustafa Al Bakri. Ladies and gentlemen, please give a big round of applause. Thank you, Captain. I request Prof to be stay on the stage because we would like to have the next session, which is lucky draw. So now, ladies and gentlemen, it is something very exciting right now. So we want to proceed with our lucky draw session 1. I would like to request Prof to stay on stage and to present the prizes of our lucky draw winners. So let's see who is the lucky winners. Excited? Excited. Let's see who's the first winner. Please do come to the stage to collect your gifts.
Sorry.
5. Number 5 is a electric kettle. Please do put your hands together. 5. We do have next winner as well. Who's the next lucky winner? Juliana, please do come and collect your gifts. The gift would be number 6. What is number 8? It's a vacuum cleaner! Wireless vacuum cleaner! Please put your hands together. For this first session, we have 5 winners. So the third one would be.
So my plan to get
Ashraf Khan. Put your hands together. And the gift would be. Number 10. And it is electric kettle.
Let's check whether your name is there or not.
Please put your hands together. Thank you. And now the next lucky winner. Who's the fourth lucky winner? Vijaya. Miss Vijaya, please do come on stage. And the prize. Number 2. Number 2. It's a hardware. It's a hardware. Please put your hands together, ladies and gentlemen. We have 2 sessions, and this we have 5 winners. So fifth. One more. We have one more winner for this first session. We have two sessions together. So the last lucky winner is. Jody! Please to come to stage. Prize is number 3. Wireless vacuum cleaner. Please put your hands together. Thank you, Prof. Please be seated. Thank you. It was exciting, isn't it? Okay, now we are going to go to our next session, which is we're going to move on to our next speaker. So, ladies and gentlemen, it is my great honor to introduce architecture Hussam Abdul Fattah Harun. He is registered architect and sustainability expert with over 20 years of experience in the field of green building design, energy efficiency, and building information modeling (BMI). He has been actively involved in both industry and academy, contributing significantly to the advancement of sustainable and digital transformation within the construction sector. Architect Hussam Harun holds a Master of Environmental Science and Sustainability and a Bachelor of Architecture honors from the International Islamic University, Malaysia. In addition, he is professionally certified as a LEED accredited professional, Green Building Index Facilitator, Registered Electrical Energy Manager, and Certified BMI Manager, which is reflecting his strong expertise in both sustainability and digital constructions. Currently, he serves as Director of Architectural Projects Team Sendirian Berhad, partner at Total BMI Consultants, and principals of Creative Environments. His areas are specializations including green building certifications such as LEED, GBI, energy and environmental stimulation, BMI and digital construction, as well as sustainable architectural design and project management. Architect Hussam has been involved in numerous impactful projects including hospitals, commercial developments, and government infrastructure. many of which have achieved prestigious green certificates at gold and platinum levels. Beyond his professional practice, he is also an academic, trainer, and an international speaker, having presented at conferences both locally and internationally on topics related to sustainable development, BMI innovation, and low carbon buildings. Today, he will be sharing his insight on topics of BMI sustainabilities, greener digital delivery cities, infrastructure, and careers. Now, it's my pleasure to invite architect Hussam Abdul Fattah Harun to the stage. Please give a big round of applause as we welcome him to the stage.
Well, good afternoon, everybody. Assalamualaikum warahmatullahi wabarakatuh. Selamat Hari Raya. We Raya for 30 days in Malaysia. My name is Hussam, architect Hussam Abdul Fattah Harun. I'm practicing architecture in PJ. I'm also the partner of Total Beam Consultants and principal of Creative Environments. So Creative Environments is the sustainability consultancy. So whenever we go into a project, there will be 3 names in the project. They will all be from the same company. Okay, we're waiting for the slide to load. Yeah, so I graduated from UIA with my Bachelor's of Architecture back in before 2014. In order for you to practice architecture, you have to have Bachelor's of Architecture. Nowadays, you need to have Masters of Architecture. So I've already passed the stage for Masters of Architecture. That's why my master's degree is in environmental and sustainability. I have huge interest in everything that has to do with built environment, sustainability, and energy efficiency. So anything to do with built environment, I will keep OT on it a little bit. Okay. Never an expert in everything, but poke my nose into almost every part of the built environment. Okay, so let me just tell you some different pointers while we're waiting for the slide to appear. Okay, so when we talk about building is, first of all, we need to understand that building is not a product. Okay, it's you don't produce something. What you want with the building is you want it to perform. So building needs to have a performance, and the performance is basically when you come into an indoor environment, you need to feel comfortable. An engineer can design a building. Azrul, I guess now. He's an engineer. He can also design a building, but he might not be able to do architecture. Okay, we can do architecture, we can do structures, but when it comes to ridiculous architectural design, like for example, we want a 20-meter suspended structure, then we'll need an engineer to solve that problem for us. So it's very, very accurate what he says just now, that engineers are problem solvers. At the same time, architects are also solving problems, but we solve problems using design. And in a built environment, you would not be able to solve everything on your own. You actually need to have, you need to work together with other trades, because building is not just architecture is not just about aesthetics. It's not just about something that is aesthetically pleasing, but it has to also function at the same time. So coming to the nomenclature today, there are three pressures that is reshaping the built environment. What are these three pressures? Okay, stress is giving a stress on the built environment. The first one is carbon. Everybody talks about carbon, right? Everybody wants to be carbon neutral. So everybody's talking about carbon reduction, lowering down carbon emission, and this goes into everything of everyday things that we do in today's life. So up to an extent, they actually came up with those sustainable development goals, which have 16 goals, and all these 16 goals, it goes into every single aspects of our life. And when you do buildings today, the requirement is for you to actually be able to produce the carbon rating or carbon scoring for your building. So you cannot actually go away from this. And when they talk about carbon, they also talk about cost. Not yet, okay? They talk about cost. When they talk about cost, one is on the cost of the building, and the other cost is on the cost of running the building. So the capital expenditure and the actual expenditure of the building, they are two different things, but they actually use concurrently together. And when we come to, okay, thank you. Okay, now we have pictures. Okay. Right. So, and what is the third word in the industry at the moment now is accountability. Okay. If you are familiar with the term CCC, Certificate of Completion and Compliance, that is for architects or submitting persons to actually take responsibility on the building that they construct or they help to design and construct. And all the buildings in Malaysia, since 2007, is issued with a certificate called CCC, Certificate of Completion and Compliance. And these are issued by the architects. And this is a lifetime liability. So the moment that building collapses, regardless whose mistake it was, whether it's the mechanical engineer, civil engineer, the first person who will be actually called to answer will be the architect. Okay, so it's a huge responsibility, but yeah, okay. We don't have the laser. Okay? Left and right only. Okay. Sorry about the typo. They say if you write in typos means that you have overload thinking process and you're thinking too much. Okay. I don't use Grammarly. That's even worse. Okay. So it's delivering. Okay, it's BIM X sustainability. Yeah. So we cannot say BMI just now because I'm not a BMI consultant. My BMI is so bad. Probably 35, 36. So I need to bring it down to what, 25, 28? Yeah, probably Puasa didn't do anything to me, so too bad. So it's BIM, Building Information Modeling, X Sustainability. These are the words today. 10 years ago, when I was a panel at one of the local university, I was the representative for the Architects Institute. So during the closing up, when they got all the panels to actually say something, I stood up and I said, there's two things that graduates needs to bring out when they graduate. This is architecture. Eh? One is they need to know BIM. Okay. If you don't know what BIM is, you should know what AutoCAD is. Okay, it's how you do drawings. So traditionally you would use T-squares and set squares, and you would draw manually, and then you move to 2D AutoCAD, and BIM is a 3D. Yeah? And also sustainability means that you need to know things like GBI and all that. So once I finished, a professor who has already spoken, he stood back up and he said, "To you, this is green, but to these students, it's 10 out. You know, like what is that? Like computer, electronic brain, they say. So to the students, it's nothing more than just computers, because as architects, traditionally, we want all architects to be able to use their hands to draw. Okay, and that actually basically shot me down. I was a young 30-year-old young architect, and then one older architect happened to, he stood up and he said, "It's BIM and green. If you have two candidates with all similar talents, same talent, same attitude, same qualities. One knows BIM and green, one doesn't know. And obviously the one that knows BIM will be an off advantage. And also enhancing careers. I'm not sure whether I'm going to talk about that, but we'll see. So this slide is a Rojak slide because I had a very wrong idea of the session today, so I'm sorry. But I think the materials will be just as interesting. How many times do we have until what time? Half an hour, 3:30, 3:35? Okay. Okay. I can talk. I can it doesn't matter whether I talk good or not, but I can talk. Okay. So if I'm a lecturer, if it's a 4-hour class, I will talk for 4 hours. If you like it or you don't like it, I can continue. Okay. Now, this is what we call an NBES. This is a National BIM e-submission. Okay. So what we do is, traditionally, you would draw building plans and you will submit it to local authority. They will reject it and you will come back, you do changes and you submit again. They reject it another time, you come back, and then this becomes like goes on and on. With the NBES system, we are trying to use the BIM to actually do self-checking. So once you have checked the system, you have checked all the drawings, everything checks out, then only you go and submit to the local authority. Okay, it might not pass on the first time, but the comments would be very, very little. Okay, because almost everything is already catered for in the NBES system. Okay, it's a BIM checker. And how we do this is we base it on a template. Okay, if you know how to use computer-aided design or computer-aided drawings, you have to have templates. So we have templates. And everything is a standardized submission format. So it means that we have set up everything in the system. So once you use this for your project, everything is already using a certain submission template protocol. Okay. And then we have uniform standardized, shortened submission process and duration means that you submit what we have tested. Previously, if you go and submit drawings, anybody here have submitted drawings before in the built environment? No. If you go and submit plans, usually it would take about, their KPI is 14 days. So 14 days is supposed to be after you submit to the local authority, to the Majlis, they're supposed to respond to you within 14 days with results. But what they do is after 14 days, they respond to you and say, "We have received your submission." Means that their processing time would be something else. Okay. But with this, what we've tried is once you submit the plans into the BIM, into the NBES system, it processes everything and the result comes out within a matter of hours. For smaller projects, it comes out within like minutes, right? And it comes out with a full report, and you can take the report and compile it together and then do the submission, right? So if they comment everything, then you can always show them what is the performance of the simulation. Okay, so the process is, you have an input. We have the NBES input guidebook and the version of the software that we're using. We started with 2018, it's 2025 now. And based on this NBES input, I'm not sure whether you know what I'm saying, and all these template guidebook software. So, but there will be images afterwards, and it will be more clear. And once you've modeled it, you put it through the modeling process by the PSP. PSP is the architect's principal submitting person. So they will model this. Okay. So if any of you are in the line of architectural technologies, this would be the direction that you'll be going at. Okay. They call it what, super beam operator. So you're supposed to know more than other people on how to use beam. So from this, the output will be IFC. IFC is International Foundation Class. It's like doing Microsoft Word and exporting it out as PDF. So it's like doing DWG and then exporting it out as IFC. And then project information and schedule, everything comes out in a certain order. And then when you put it through the system, it will be tested based on the rule sets. Rule set means that we use simple logic. For example, what is the height of the door? Has anybody checked the height of the door? What's the height of the door? Do you know the height of the door there? 2,100, okay? In normal terms, we say 7 feet. So what is the width of the door? 450. Okay? The width of the door, based on the bylaw, has to be not less than 750. And then there's a calculation to it. And then this door here, well, it's not a fire door, but it has a requirement for the keluar sign. Do you know why it needs to have 2 doors here? Why do we need 2 doors? Why cannot we have just 1 door? So in another forum, I said, why do we have to have 2 doors? One said, oh, if somebody is presenting here, it would not be very nice to come in from the back of the person talking. That's not the case. The reason why we have 2 doors is based on the bylaw. Is the space is occupied by more than 6 persons, then you need 2 doors. And that's a requirement. That's a requirement for the size of the window at the back there, for lighting and ventilation. So what is the size of the windows that you need? Why does it have to be that size? Can it be smaller? Should it be bigger? The requirement is 10% for the per floor area. So all of this is set up in the rule set. The rule set will read the 3D model and tell you whether the rule set is fulfilled or not. Then you get a pass and fail. Okay. Yeah, and then we need to have the modelers to know how to model it, obviously. And then everything comes in the schedule like this. So the modeling approach is because the buildings that you are in, all of these spaces are properly commissioned and approved by the local authority, right? So, for example, in the bylaw, you know what the bylaw is? The UBBL, the Universal Building Bylaws. We have to build. That's the what do you call it? That's the standard for doing buildings. For example, what is the height of the steps? These steps here. What is the height of this? Right? There's a minimum height. There's a maximum height. Right? Cannot be less than 150. Should be more than 180. So once you have this, so that when you walk, they have enough population sample to know what is the height of a person who can lift their leg and then climb this, right? And then this is called a riser. Coming up here is a riser. Going this way is called a tread. What is the maximum of a tread before it becomes a landing? So a tread means that when you come up, you can go, right? When it's a landing, means that you come up and then you have to walk a little bit. You have to probably add 1 more step, right? And these are all standardized to the fact that you can actually come down the steps here without looking, right? Because it's ergonomically designed with your body, right? So when we certify a building, the building is certified based on the units. And when you purchase a premise, you are purchasing that unit there. So we need to make sure that every single unit complies with the requirement of the authority. Okay? So we would combine them together and then this will be tested. So we also have a modeling approach for high-rise, Okay, and then we put it into the template. So there's a site element, building element. From here on, it's going to be all pictures until 3:30. Okay, we have road modeling, fire requirement. Fire protection and requirements is key. Okay, if you go and submit, if the fire requirements are not met, the entire thing will not be reviewed by Bomba. Bomba is the fire department. They will not review it. They say, oh, because the site requirements are not met, we might as well not review the building. So they will push it back to you. So you have to review back everything. Okay, so this system helps you to ensure that system complies. Okay, we have the roads, and this is how the roads is modeled. So there's a certain way to model this, and it makes sense. Now you know why you should not double park. Now you know that we know that why you should not park on the roadside. If there's no parking bay there, you should not park there. The moment there's a fire happen in say unit number 3, when the fire truck comes in, they will not be able to access the site, the fire, because somebody is selfish enough to be parking on the haphazardly on the non-designated parking area. Okay, so these are all Bomba requirements, and there's a requirement for the hydrant. Like, how many types of hydrants? How many colors hydrants have you seen so far? 2. What colors are there? Yellow and red. What is red? What is yellow? One by Bomba. Okay. One is by the authority, not Bomba, by the municipality. So it's public water. The yellow one, which is inside your site, is owned by the compound. It's your own water, right? And that's a distance from that hydrant to the building, from the hydrant to another hydrant. So all of this in the system, you'll be able to track their position, their distance, whether they comply with the requirement or not. Okay, and then there are things like for building, so there's wall, rooms, doors, staircase, airwells, travel distance, and all this. So all this goes into the modeling process. And as architects, we model this with intuitively. While we're modeling, we know what the requirement needs to be there already. We don't model and then we test, right? The training of an architect is that you are supposed to design in 3D. Means that while you design for compliance, you design for aesthetics, you design for construction, you design for cutting corners sometimes. I don't do that. Okay, and you have all these types. So we make sure that all of this is input into the BIM model. And these are how we lay out the rooms. Okay, we have doors and windows, staircase and ramp, airwells, toilets. So all of this goes into a main data sheet. So from here, the local authority, when they receive this, they'll be able to do their own checking on the submission before actually doing the checking per se. Okay, so this helps to minimize or make sure that the checking process is more streamlined. Okay, and then things like project input, PSPs, and up all the way up to green building properties, which we're going to go in very soon after this. Okay, schedules, all these schedules, they're all there. Okay, and then what we have is we have this schedule that comes up. Once you finish this, those lines there are called running distance, right? What is the running distance from the furthest end here to the door? So look at the room here. It has sprinklers. The moment it has sprinklers, the running distance is allowed to go longer by 3 times. Okay. If you don't have sprinkler, the running distance will be 15 meters. With sprinklers, Bomba allows the running distance to be 45 meters. Okay, that's telling you that the building is safer. So meaning that the building allows for a longer time of evacuation. So we will draw this, we will draw all those running distance line, and then it will come out in this table. Obviously, it's fire hydrant table, but okay lah. It says here, what is the marker length? Is for the first one there, count is 1, is 9,966. The requirement is less than 30 meters. So comply with the requirement already. Okay, and all of the other ones as well. And we put in all these elements. These are all in the BIM environment. So we just do clicking, changing settings and all that. So the moment we check, when it comes into the site compliances, the moment we check the requirements and it doesn't comply, then we can always go back and do some tweaking on the model, right? So it makes sure that you are designing things right from the first time. Okay, some more complex layout. Okay, giving you all the requirements for, these are all requirements for fire, for bomba to actually access your site. Okay, number of hydrants. And for this site here, once you come in, this one will make you look every time after I say this. When you go into a new site, okay, the new development, you come in through the gate, right? What are the things that bomba will check first? Bomba wants to see what is the height of the entrance. The height of the entrance must be a minimum of 4.5 meters. Usually we will design for 4.6. This is to allow their fire truck to come in, right? So if you go into a residential project and then they have like their guardhouse and it's like this, and suddenly this one is short, the height part there is on purpose because they want to allow bomba to be able to come in. Okay, not just bomba, the compactor also will require some height for them to come and collect this. And what else do you check once you come into the site? Once is the height of the entrance. The next thing that you will check is you will be checking for the fire hydrant. So the fire hydrant here, based on the requirement of the bylaw, it has to be not less than 30 meters. So that will determine the first point of where the hydrant should start in your project. So this modeling will actually check on the first hydrant, and then all the subsequent hydrants have to be less than 90 meters. Okay. Right, compliances. You notice that your building always have those wall jutting out from your roof. Those are also fire requirements. It's called the wall separator, or party wall, we call it for house. So that is to ensure that if, say, unit number 3 there is on fire, the fire doesn't go and flash over the unit next to it. Okay, so that's why you need to have that thing jutting out from your roof by 230 mm. Okay, it's by design, it's a requirement. Okay, we mentioned this already. Okay, and then room space. This is another thing that you would like to go and check. Okay, when you go into a staircase, especially the protected staircase, look around for additional things that are inside there. So do like you're doing a treasure hunt. So when you go into a staircase, what else is in the staircase? If you go into the staircase on this side, what is inside there? If you go in the staircase on this side, what is inside there? Once you go into that staircase, what's the first thing that you find? This one on this side. I just went through it just now. Oh, a what? Somebody answered. You have to speak up. Student, if you're a student, then speak out more. Okay? When you go into this staircase on this side, the first thing that you see is a lift. That is a protected shaft, we call it, and that lift is a requirement for bomba, right? And somewhere inside that shaft there must be a protected staircase, and there must also be a riser mains. Means that there's a riser for water to come out. That's where bomba will come and couple their system to fight fire. Okay, so everything is by design, and all the doors that you see there, when they have the sealer tutup, pastikan it has to always be closed. Those are all by design. Okay, it comes up with all of this, all this checking. Okay, and then yeah, right. So now we move on to the green building. So green building is a certification system These are old slides that went into a new PowerPoint, so I think some of the things were missing. It's something is strategies within the green building system. When you comply to them, you'll get points. Okay. But the real reason for you to do this is actually to not to just get the award, but it's also to get make sure that the building actually performs, and you'll get a plug like this. So what we do is missing. When you do a green building certification, you will require all of the consultants to work together. So you need architects, M&E, CNS, QS, everybody. Okay, and there's a sequence to this before you actually get to go to your final certificate. So these are the process, and you are required to. Is the process for green building is prevalent in all stages until occupancy in order to make sure that there's performance. Okay, so these are the points. So I'm going to skip this. We are running out of time, and there's a cost there as well. Looking at how the step by step. So these are all the strategies. All the strategies are there. So we can actually test using BIM model and also computer simulation for energy. We can actually model what is the impact of the first one, having horizontal louvers. When you add louvers for your building, what is the impact? The impact is you get to reduce by 13%. And this is okay because the payback period is 1 year. So we put in like 20 steps, and along the way we test them one by one. Okay, and we are able to produce this graph here showing that the more strategies green building you put in, the lower your energy becomes, right? And the more savings. So you're lowering your energy, it translates directly to saving energy at the same time. Okay, and you do like solar, and we do like analysis. So this is analysis that we did for building in Bangsa. So this is how it looks like with the sun. So this is a sun path diagram, and this is the conditions of the facade over the time of period of the day. Okay, and because people always say that the sun is on your roof, but when it comes to tall structures, the area that is exposed is actually your facade, and you need to actually shade your facade. How do we shade it? So those are the shading that is already proposed in the project. So we tested this, and then all the circle there shows the sun patch. So if you are from a temperate climate, you want to have those sun patch inside your building because it helps with your air conditioning. In Malaysia, you don't want those patch. So we are looking at those patches and we're trying to remove those patches. So this is at 10 o'clock. And that's the reason why we put there 21st of March. There's a reason for that one. And this one, 10 o'clock, 10:30, 11, 11:30, 12, 12:30, and about 1 o'clock, then there's no more sun patch. So we know from this that you need to actually cover the windows from direct sun penetration from 10 o'clock to 1 o'clock, 10, 11, 12, 1, 3 hours. So how to do that? And then we move on 1:30 to, and from 2:30, it starts coming out on the other side. Imagine this, at 1 o'clock to 2:30, this is the time when you leave the office, go lunch and have all that. So you are in the office when the office is hot. When the office is shaded, you are not there. And then you come back again when the sun is coming in. 3 o'clock, 3:30, 4, 4:30. Okay? So we propose, instead of just having the 2 shading, do 4 shadings, right? To enhance the shading potential, and still allows for view. When you stand inside, you can still see view. And there's other options, you can do it like that. Okay, sorry. The result is not there. Okay, so what we did is, eventually, you get the building just now gets to remove all of the sun patch inside the building. The energy from cooling was reduced by 18%. Yeah? So they're saving millions per day. So this is, if you are familiar with Shah Alam, this is coming to the end. There's a building called Space U8. This was the original design. And they have this huge skylight on above the concourse area for daylighting. Okay, and when we went to this project, they only wanted to see whether the ventilation works around the corridor or not. If you understand CFD, you cannot run a fluid dynamic simulation without a boundary condition. So we needed to test this. Okay. So one of the things that we found out that the top of because the skylight is concentrated, it's very hot on the top. Okay. So we proposed to them a few ways to actually change the skylight design, and eventually they came up with this. Okay, they came up with the roof factory design, and this makes the skylight more distributed. So that was the original design, and this is the final distribution after the design, after the enhancement. And this is how it looks like from. You see, if we went with the original design, the corners of the concourse would be very dark. Okay, so once we change this, the condition inside the space is a bit more even. Okay, and this is the artist's impression of the space. This is the actual space, right? It's so airy. They have all those big fans there, which also help with the ventilation. They can put water features, and it's basically thermally comfortable. Unfortunately, this place doesn't thrive because of the position location. It's a bit too outskirt. But this is the result. It's a proof that once you simulate and you design properly, you can get a results that comes out properly. Okay. So as a conclusion, when you model your building with BIM, then you'll get to know what are all the problems before constructing it. So it's like, have you ever tried to teach anybody anything? So you want to teach somebody language. You have to learn the language in order to teach the language. So it means that if you have to teach someone, you have to learn twice, right? So doing building checking using BIM is that you have to test the BIM, the model, the design in a virtual environment before you actually do the actual construction at site, right? So that makes sure that all the problems that can be avoided is avoided at design stage. Okay, and when it comes to green. People think that green is imposing. You must. But it's supposed to facilitate. Yeah, you see how it works with the system, and it shouldn't be expensive. Putting expensive things in the building doesn't make it green. What makes it green is when you do something and it performs to the level that you want, and it's easy actually. Green is actually very easy. And it's parallel with the project timeline. It means that by the time the project is completed, you must be able to see the performance. Okay. And how is it different? It's because we need to have a clear system. We need to have proper minutes. Everything is good when it's done in-house. Okay? And we don't impose, we facilitate. Thank you very much. My time is good?
Yeah, good. Is there any questions? Would you like to ask questions?
Yes.
Thank you for your talk. It's been always interesting, first architecture design. So I believe Malaysia also applied this MICRES and Green RE.
Yes.
How it is incorporated with the GBI?
Oh.
Are they really affecting MICRES, or the GBI do their own things and
Okay, there's another lecture on sustainability. Okay, and if you take sustainability, if you just go backwards, let's go back to the time. Okay, now it's relevant. Back in the 70s, there was an oil embargo, right? Where the Arab nations, they stopped supplying energy to the West. And immediately a few things happened. One is the daylight saving was introduced. Speed limit of 50 miles per hour was introduced. Yeah? So this Not because like here in Malaysia they go and shoot you when you're driving fast because they want to summon you, right? But in the US, when they check you for speed limit, it's because you are burning more energy than other people, right? That's the reason why they have this. So from the movement of sustainability, daylight savings and all that. From the movement of sustainability comes all this movement of energy saving, indoor environmental quality, water efficiency. And eventually, in the late 90s, all of these components are combined together and they fashion it as green building. So there's there's BREEAM in the UK, LEED in the US, CASB in Japan. In Malaysia, in 2009 was GBI. Okay, so GBI was the rating tool that is set up for the tropical climate. Okay, how is it different from Singapore? In Malaysia, the GBI stresses more on energy efficiency. In Singapore, energy efficiency is a mandatory requirement for energy reduction. And then they put a big stress on water efficiency. Okay, and probably you've heard in Singapore, water is owned by the state. You cannot take water if you takung water and you use it, you're actually stealing from the state. Okay, also in the US, some states in the US, water from precipitation that falls on your land is owned by the state. Okay, so in terms of approach, they are in terms of categorization, they are similar. Means that they all talk about energy, environmental quality, material, water. In terms of where the weightage is different. So for GBI, the weightage is energy, indoor environmental quality, right? For Green RE, because they actually took it from the Singapore Green Mark version 2 and fashioned it with Malaysian rating, with Malaysian standard. My class, on the other hand, was an academic work, okay, and converted for use for CIDB. And it focuses on carbon reduction. So if my class is different, in terms of its design and construction is similar, but it also have the carbon calculation, which GPI doesn't have.
Yeah, just nowadays, all coming to the work from home, composing by government.
Yep.
Do you think Malaysia ready for that? Because if you stay home, you will use more aircon. Is it which one more cost effective?
Oh,
To
okay.
drive to office or to stay home and use aircon? Because maybe other countries they don't need to use aircon. But Malaysia, everyone you will stay home means more aircon, more energy. Sorry, it's a bit political, but
Prof, how much is your electricity bill? I'm trying to open mine. Okay, lambat. It doesn't come up. My electricity bill at home is 70 ringgit. Yeah. I have no aircon, right? And is it comfortable? On the most days, yes. When it's like super hot, see here. It's only, yeah. So over the last couple of days, it's higher, like 150, 1998, 99 ringgit 20. This one is the least, cannot press this one up. 16 kilowatt hour. That translates to, doesn't say here. Okay. So 20 years ago, how old are you guys here at the back? How old are you? I'm 20, 20, 26, 19. Okay, back in the day, all houses in Malaysia is designed for natural ventilation. The bylaw today is still natural ventilation. Means that you need to provide 10% natural ventilation, 5% uninterrupted natural ventilation. Right? But actually it's no longer relevant because you're going to close everything and you're going to aircon it. Okay? 20 years ago, in 2003, I was 22 years old. Okay? So not very old. So this one is different. This one is too much talking and come on. when I was in my 20s, when we design a house with aircon, the aircon is a lifestyle. Only rich people have them, right? Today, you cannot design a house without putting an aircon. It's a necessity today. So now times have changed, okay? And certain works, we've tried, with BIM, we have staffs in Sabah and Sarawak who still work for us until today. So these are our, we call them the Borneo boys. Okay, these are our offshore staff. Okay? We also have a staff in Penang, because when you do BIM, all the models are centrally located in our office, and then they link to the office, and then they work from home, and we get to see their hours, their performance, and when we need to speak to them, the camera will just switch on and you can talk to them. So no issue. Thank you very much. Okay, but when it comes to things like architectural design, so my architects and the junior architects, they are always screaming at each other. They have to be in office. So it really depends on the type of work that you do. Okay, um, I have a, there was a complaint that was mentioned to me. Those, when you do high-rise buildings, there are those scaffolding on the outside. There's always a name there. One of those names actually have a very big BIM team, right? And then they went public, listed public, and then suddenly some of the other departments, they were complaining, hey, why this BIM doesn't have to be in office? So everybody have to be in office. Their BIM sector, department within their company collapsed because their offshore staff cannot perform because they have to come to office. So if you ask me, what comes up from COVID, and what comes up from COVID is that the Malaysian chapter of the American, what's ASHRAE, ASHRAE, American Society for Heating, Cooling and Refrigerant. Okay, the Malaysian chapter came out with a standard for ventilation, and now it's being used for all of the of tropical climate countries like Brazil and Guinea. Yeah? So they actually have this. They use the standard that was developed in Malaysia for for domestic ventilation for areas where it's tropical. If we actually need people to work from home, one is the nature of work. And then if they have to work from home, there need to be some level of standardization of work. If they have to work from home and they are in the living room and the kids are also playing there, the TV is open, the wife is cooking in the kitchen, and then for me, that's not a working environment. So it needs to be managed in a certain way. My view. Thank you.
No more questions? Okay, thank you.
Thank you.
Thank you for the wonderful insight session, Architect Husam Abdul Fatah. I would like to request Architect Husam Harun to remain on stage to receive a token of appreciation. I would like to invite our Dean of Faculty Engineering, Built Environment and Information Technology, Associate Professor, Technologist Dr. Iman, to come to the stage to provide the token of appreciation. Put your hands together. Thank you. And now we would like to move to our second lucky draw session. So I would like to request our respected and also to remain in stage, and we want to provide all of the winners. I would like to invite Miss Howie, our Deputy Dean School of IT, to present the winners of lucky draws. This is the final session, session number 2. We have 5 winners here, final 5 winners. So let's see who's the first winner. This one, please come on the stage. And the gift would be number 4. Number 4 is a hardware. Please put your hands together. Next, our second lucky winner next is Ismail Musa. Is he here?
Calling once. Calling once. Calling once. Calling once.
Is there Ismail Musa? Ismail Musa 1, Ismail Musa 2, Ismail Musa 3. No? Okay, I'm sorry, I have to change the winner. Still in our second lucky winner, and who is it? It's Wang Jimmy. Wang Jimmy, please do come to stage. And the gift would be gift number number 9. Number 9 is also a hardware device. Please put your hands together. Next is our third lucky winner. Who is it? Who is it? Who is it? Next is Maisara Binti Lutfi.
It is Kegi.
And the gift is number 1. Number 1 is power bank. Okay, last final 2. Who's the last final 2 lucky winners? Siti Rahma. I have it. And the okay, let's look what gift. What is the surprise gift? Number 6. Number 6 is also a power bank. Okay, we have one more last lucky winner. Who is it? Who Who is it? Who is it? One last lucky winner. Natalia! Up also. Put your hands together. Okay. We are done with our lucky winners, with our lucky draws as well. So now we are moving to our next session. Ladies and gentlemen, now I'm very honored to invite our Dean, Faculty of Engineering, Built Environment and Information Technology, Associate Prof. T.S. Dr. Iman, to give a speech, a closing speech. Please do invite a warm welcome to Prof. Please put your hands together.
Good afternoon, everyone. So I won't take this line time because I know everyone are very excited to know who is the winner. The winners is still not announced, isn't it? Okay, so everyone, I'm pretty sure that they are very excited that to see who's winner or not. But in my opinion, I think all of you are winners. I wasn't around too much, but I just have a glance based on the pictures and so on. And I really enjoy all the projects. I mean, all of you. So before we going to announce, so I really congratulate all of you that you are all winners. So we can clap off for us. So the reason that I'm telling you all of you is the winner for the age that everyone use AI for everything. Even I mean maybe I could prepare my speech or everything by AI, and even sometimes with the simple message you use AI. But I see these projects that you prepare is creatively and amazingly show how you are creative mind, how you are able to make sure creatively prepare your final projects. That's why I really enjoy that in this age that everything's AI can prepare for you, still your creative mind is very important. That's why all our engineering attributes and all our students, they must know that not only getting the knowledge is important, however, to become a successful person here, analyzes creative thinking and solving a complex engineering is very important. And today you all of you show that how complex solving complex engineering problems related to the real case studies is very important rather than just simply use AI. So one more time, I congratulate all of you. I hope that today you had a great day so far. You received most of you the feedback from the panels. I hope you consider those feedback positively to apply it to your future projects. Make sure that feedback is for you to improve. It is how to understand other students working and how to improve your works in the real work when you are doing your real studies. So I think that's all, and wish you all the best, whoever the winner. Great job. Thank you so much.
Next session is, of course, your award-winning ceremony. For now, I would like to, Prof, I would like to invite you to the stage to present the award. Okay, first. I would like to present the award for academical level, silver optimizing, converging, diverging nozzle, geometry for rapid inflation of aircraft evacuation slides. Please do come on stage, Dr. Shazli, Dr. Muhammad Noordin, Mr. Aidil Azlan, Mr. Muhammad Khairul, and Dr. Maisara from Masa University. Proudly presenting Silver Award. Please do give a big round of applause. Next is the Gold Award, which is presenting to the title Green Synthesis Gold Nanoparticles Nanofluid for Solar Harvesting Technology, presented by Dr. Siti Rahman and Dr. Ali Dayana from the University of Technology Malaysia, UTM. Please put your hands together. Next is degree level award presentation. I would like to start with Silver Award for the title DRAM-based physically and clonable function memory controlled for key generation in FPGA-based system by Dr. Siti Rahma, Tan Wei Jian, Wang Jimmy, and Orija Yi from the University Technology Malaysia, UTM. Please give a big round of applause. Next is Silver Award. Title is AI-based electrical energy consumption forecasting, which is by Victoria Raina R, Samiha Banu, by Wesley K, Aishina Judith from the University Francis Xavier Engineering College, Tamil Nadu, India. Put your hands together. Next would be Bronze Award by the title of Care Lens by Samuel Paul A. and Kalasri Varshini from the University Dr. MGR Educational and Research Institute, Chennai, India. Next is Bronze Award for the title Autonomous Charge Rescue Net by Vinila Modugula, Amuluru Madhuri Prasad, and Janani KG from the University Dr. MGR Educational and Research Institute, Chennai, India. Next is Gold Award for the title Mirzol, a smart digital solution for structured learning by Dr. F. Fariza, Robina Jubi, Joel Jayed, Muhammad Aidil A. From the University Dr. MGR Research Institute, Chennai, India. Please put your hands together. Next is Gold Award for the title Smart Integrated Control System for a Continuous Flow Algae Wall in a Confined Space by Dr. Siti Rahman I, Insanti Hanifa Shukri, Siti Aisha Binti Maizu, Liu Mi Chua Ming Wen. From the University of Technology Malaysia, UTM. Now, moving on to degree level individual. The first is your Silver Award with a title of Experimental Study on the Thermal Insulation Properties for Bambusa Vulgaris for Sustainable Building Construction by Makfu Rusta Tino Wimba and Zakaria Alan Samuel Mikaya from Masa University. Next, Silver Award for the title Development of a Solar-Powered Food Dehydrator with Integrated Battery Backup for Off-Grid Operation by Muhammad Imamul Haq by Masa University. Is there any representative for Muhammad Imamul? Is the supervisor here? Thank you. Please do give a big round of applause. Moving on to Bronze Award for the title IoT-based Smart Street Lighting Optimizing with Solar Panels and Batteries for Energy Efficiency by Dr. Noraida binti Muhammad Shafir and Girisha Shivani Anak Perempuan Balachandran from Segi University. Bronze Award go to the title of Bullet Impact Analysis on Honeycomb Sandwich Panels by Fawad Ashab Khan from Masa University. Put your hands together. Bronze Award go to the title of An Economic, Energy Efficient and Intelligent Irrigation System by Mr. Chong Kok Siong and Shanti Tanabalan from Segi University. Moving on to Gold Award for the title Analysis of Coolant Installed Waterproof and Floating Panels for Higher Power Generation for Solar Energy by Muhammad Abu Bakar Muhammad Tong and Muhammad Al Hassan from Masa University. Next Gold Award goes to the title Skillshare Platform by Khaton Monia from Masa University. Next Gold Award goes to the title T-joint of magnesium AZ31B with aluminium powder using gold low powder microwave welding by IR Dr. Shamini Jayasekharan and Varshan Raj Vijayan from Segi University. Moving on to diploma level, the first would be Silver Award for the title Smart 80s Detector by T.S. Dr. Tinagaran Narayanan, Vijaya Anak Perempuan Sengodan, Muhammad Khairul Naim bin Muhammad Zakaria, Muhammad Hakimi bin Muhammad Akmal Shahril, Muhammad Zuzaid bin Norazman from the University Institute Kemahiran Tinggi Belia Negara, Sepang. Next, Bronze Award goes to the title Harvest Vision AI Powered Smart Freshness Classification System for Fruits and Vegetables by Wang Yu Ming, Alia Nurfarisha binti Zurami, Aloysius Lim Ming Zhu, and Leong Q N from the University of Sunway College, Kuala Lumpur. Please do give a big round of applause. Moving on to the next Gold Award for the title Plastic Product Quality Inspection System by T.S. Dr. Tinagaran Narayanan, Vijaya Anak Perempuan Semboden, Nia Zulta Akma binti Syam, Shah Jan I'm Rosie bin Mohedin, Shah Bahriswaran Anak Lelaki Paramalingam from the University Institute Kemahiran Tinggi Belia Negara, Sepang. Moving on to Gold Award for the title Tutor Buddy by Fu Chuan Zung and Nikolai Lin from Sunway University. Please give a big round of applause. Next, moving on to school level.
Thank you.
Just due to hybrid or school level, we would like to announce the Gold Award for Safe Quick, which belongs to Dainaira Zakia Rashid, Ziniel Almera Britannia, Quintinsa Malik Rai, Maya Seruni Jacobson from Mentari International School, Jakarta. Moving on to Potential Project Award for the title IoT-based Overload Discrimination for Control and Monitoring of Protection System by Mr. Chong Hock Siong and Danny Muslim bin Muhammad Jairamin Eng from Segi University. Please put your hands together. Next Potential Project Award goes to the title Analyzing the Prospective Advantages of Permeable Pavement for Water Runoff in Road Construction by Annie Noriana binti Hasim by Masa University. Is there any representative? May I have the supervisor on stage? Next, moving on to the Best Poster Award for the title Data Mine AI by Dr. Damodaran Usha, Rahul Ganesh Sri Kesavan, Madhumita Kesavan from Dr. MGR Educational and Research Institute, Chennai, India. Please give a big round of applause. Moving on to the next Best Poster Award for the title Smart Fresh Keeper System, a low-cost, easy-to-maintain solution to extend produce freshness in Malaysia's hot and humid markets by Dr. Siti Rahma Ai, Liu Po Chuan Ming In San bin Hanifa Shukri, and Siti Aisha binti Maizu from University Technology Malaysia UTM. Moving on to the Best Demonstration Award for the title Design and Development of an Interactive Educational Website for Preschool Children from the age 4 to 6 by Siti Nur Hikmah binti Abdullah from Masa University. Moving on to the next Best Demonstration Award given to the title of Smart Mirror Technology by Sahaya Raj, Francis Vincent Emmanuel, Pon Subburaj Kalimutu, Ruben Stephen, Gana Kumar, and Alfreda Janeline Navaraj from Francis Xavier Engineering College, Tamil Nadu, India. Please put your hands together. Next, moving on to the Best Presenter Award for the title IoT Enable Multi-Hazard Navigation Assistant by Bro Ming En from University Technology Malaysia, UTM. Please put your hands together. Next Best Presenter Award goes to the title of AI Driven in Silico Screening of Marine Natural Products for Targeted Cancer Therapy by Danur Shruti Saravanan from Dr. MGR Educational and Research Institute, Chennai, India. Please give a big round of applause. Next Best Project Award goes to the title Carrier Lands by Samuel Paula and Kalasri Varshini from Dr. MGR Educational and Research Institute, Chennai, India. Please give a big round of applause. But last but not the least, the most innovative and creative award. The title goes to Material Properties Testing of Play 3D Printing by Leon Kaizen from Masa University. And lastly, the most innovative and creative award for the title Online Appointment Booking System for Masa Clinic by Lodi Wei from Masa University. Congratulations to all winners and well done to all participants. May please be seated. Ladies and gentlemen, please direct your attention to the screen for a special faculty montage presentation by our media team. Heartwarming, right? Okay, ladies and gentlemen, as we come to the end of ST 2026, we hope today's event has inspired you continue to innovation and shaping the future. And also, I would like to announce all participants will receive their e-certificates. So, on behalf of Masa University and organizing committee, thank you for your presence, participate, and also your support. With that, I proudly declare ST 2026 officially closed. Now we will have a group photo session. I would like all of you to rise and come closer because we want to take a group photo from here. So can you rise? Can you come move closer? Can you please come to the center?
Sit down or stand up? Okay. 1, 2, 3. Sit up.
Thank you everyone for today. Balik, balik, balik.